Have you ever stopped to think about what actually keeps our modern world ticking? From the car you're driving to the clean water coming out of your tap, there are these hidden digital brains working 24/7 behind the scenes, orchestrating this incredibly complex dance of machinery. Well, today, we're going to pull back that curtain and meet these unseen workhorses. And this is it. Meet the hero of our story, the Programmable Logic Controller, or PLC. Now I know, it doesn't look like much, but this little box is genuinely one of the most important inventions of the 20th century. It is the unseen brain that powers pretty much every factory and every piece of critical infrastructure on the entire planet.
So, to really get why the PLC was such a game changer, we have to hop in a time machine and go back to the 1960s. Because the problem it was designed to solve was massive, it was inefficient, and it was just a tangled mess of wires.
I want you to picture an entire wall, maybe even a whole room, just covered in this crazy web of clicking electromechanical relays and timers. Now, if you wanted to change one tiny thing in the assembly line process, you'd have to call in an electrician who would then spend days, sometimes even weeks, physically rewiring that entire panel. It was painfully slow, it was super expensive, and just one wrong wire could grind the entire factory to a halt. It was a nightmare. The auto industry, and General Motors in particular, was absolutely desperate for a better way. They needed to be more flexible, they needed to be faster, and that huge demand led to a breakthrough that would change manufacturing forever. So, in 1968, this engineer named Dick Morley and his team invented what they called the Modular Digital Controller, or Modicon, and it was brilliant. It replaced all those physical wires with software logic. Over the next couple of decades, it just exploded, going from this niche fix for GM to a global standard. PLCs learned how to talk to each other using protocols like Modbus, and they got powerful enough to plug into these huge supervisory systems called SCADA that could control entire plants. But there was a catch. See, early computers used programming based on Boolean statements, and, or, not, which is great if you're a computer scientist. But for the factory engineers, the people on the ground who were used to reading physical wiring diagrams, it was like trying to learn a completely foreign language. It just didn't click. And this is where we get to Dick Morley's real stroke of genius. He didn't try to force engineers to become coders. No. Instead, he created this visual programming language called ladder logic that looked exactly like the relay schematics they had been using for years. That was the key. It was familiar, it was intuitive, and all of a sudden, reprogramming a massive industrial machine was as simple as dragging and dropping symbols on a screen. For a while, though, it was kind of the Wild West. Every single PLC maker had its own software, its own way of doing things. It was chaos. Then, in 1993, this game-changing global standard came out, IEC 61131-3. And what it did was create a common framework, a common language, so an engineer trained on one type of PLC could, actually understand another. The standard officially defined 5 different programming languages, which you can see right here. And while that classic ladder diagram is still probably the most popular, this new flexibility meant that programmers could finally pick the absolute best tool for the job, whether it was for simple on-off logic or really complex data processing. The standard also created a structure for how to build programs, using something called Program Organization Units, or POUs. The easiest way to think of them is like Lego bricks. You've got your main program brick, which is the core routine, then you have reusable function blocks that can remember things, like timers, and then you have simple functions for quick little calculations. This whole modular approach just makes the code way cleaner, more efficient, and so much easier to troubleshoot and reuse. Okay, so let's fast forward to today. PLCs are, you guessed it, smaller, faster, and way more powerful than anyone could have imagined back in the 60s. But with all that incredible evolution comes a whole new set of pretty serious challenges. Now, you might also hear this other term floating around, PAC, or Programmable Automation Controller. The lines are definitely getting blurry, but here's a simple way to tell them apart. Think of a classic PLC as a specialist. It's amazing at controlling a single, super fast machine. A PAC, on the other hand, is more of a generalist. It's like a hybrid of a PLC and a PC, and it's built to manage huge, complex systems with tons of data. And this right here is the critical point for the modern era. As all these devices get plugged into company networks and even the internet, they become the nervous system of what we call Industry 4.0, the smart factory. But opening that door to the outside world also opens them up to some new and really serious dangers. Here's the scary part. PLCs were never, ever designed with cybersecurity in mind. They were built to be isolated. This makes them a huge target. We're talking about malware like the infamous Stuxnet virus, which physically destroyed nuclear centrifuges in Iran by taking over their PLCs. We're talking about ransomware that can shut down an entire manufacturing plant, and attacks that could literally disrupt our power grids and our water treatment facilities. The stakes are incredibly high. So, how do we protect them? Well, it really comes down to solid cybersecurity fundamentals. Things like isolating the control networks from the business networks, constantly updating the software, having super strong access controls, and always monitoring for anything that looks suspicious. These things aren't just nice to haves anymore. They are absolutely essential. All right, but looking ahead, the story of the PLC is about to take another really exciting turn. The next revolution is already kicking off, and this one is being powered by artificial intelligence. AI is basically giving these PLCs a massive brain upgrade. They're going from just following simple instructions to becoming intelligent partners. We're already seeing systems that can generate their own code, troubleshoot problems on the fly, and even understand plain English commands. And maybe the biggest deal of all, they can analyze tons of data to predict when a machine is about to break down, preventing hugely expensive downtime. Okay, so here's the big question on everyone's mind. Does this mean AI is coming for the engineers' jobs? Well, the consensus is a pretty clear no. AI is an incredibly powerful tool, for sure, but it just doesn't have the hands-on experience or the creative intuition you need to design, install, and fix these complex systems. The goal isn't to replace people, it's to empower them. Let AI handle the boring, routine stuff so that engineers can focus on innovation. So from a tangled wall of wires to an AI-powered partner, the PLC has come on an incredible journey. It's still that quiet, reliable workhorse of industry, but as it gets smarter and more connected, it forces us all to ask a much bigger question. In a world of truly intelligent automation, what is the future of human expertise? What does it really mean to be an expert?